So what if I told you that a number that was once dismissed as, well, impossible is the very reason your phone works and your lights turn on? Today we are diving into the story of a mathematical fiction that became a cornerstone of our entire modern world. This is the story of complex numbers.
Okay, let's start with a puzzle. This one actually stumped mathematicians back in the 16th century. It comes from an Italian scholar named Girolamo Cardano. He asked, can you find two numbers that add up to 10, but when you multiply them, you get 40? Now, at first that seems pretty straightforward, right? But as Cardano and, well, everyone else at the time discovered, there are no real numbers that can solve this thing.
All right, let's turn Cardano's puzzle into algebra, see what's really going on. If we say one number is a, then the other one has to be 10 minus a. Simple enough. Then you multiply them together. A times 10 minus a equals 40. A little rearranging, and boom, we get this classic quadratic equation. So far, so good. The trouble starts when we actually try to solve it.
Because when you pull out the trusty old quadratic formula, you just hit a brick wall. The answer involves the square root of -15. For Cardano, this was a complete dead end. I mean, it's a mathematical absurdity. Think about it. Any real number you can imagine, positive, negative, doesn't matter, it always becomes positive when you square it. So, how could you possibly find the square root of a negative number? It was, quite literally, an impossible number.
And this wasn't just some weird one-off puzzle. This impossible kind of number just kept popping up in the solutions to very real problems like cubic equations. It was haunting mathematicians for centuries.
So, how do you solve an impossible problem? Well, you don't give up. You change the rules. Mathematicians just defined a new number. They called it I, the imaginary unit. And its definition is so simple, but it is absolutely revolutionary. I is the number that, when you square it, equals -1. Just by inventing this one number, they created an entire new mathematical world.
And with our new number I, we can finally solve Cardano's puzzle. The square root of -15 just becomes I times the square root of 15. So the two numbers are 5 plus I times the square root of 15 and 5 minus I times the square root of 15. And check this out. Add them together, you get 10. Multiply them, the I squared becomes -1, and you get 40. The algebra works out perfectly. It's wild.
But not everyone was on board. The great philosopher and mathematician René Descartes, he's the one who actually coined the term imaginary for these numbers. And trust me, he did not mean it as a compliment. He basically saw them as a kind of mental fiction, a place where the math worked, sure, but reality didn't seem to follow.
And look, you can't blame him for being skeptical. For these new complex numbers, that is, numbers with both a real part and an imaginary part, to really be accepted, they had to be more than just some clever algebraic trick.
The huge breakthrough came when mathematicians realized you could actually visualize these numbers. The Argand diagram, or the complex plane, it gives them a home. So instead of just a single number line, you've got this two-dimensional plane. The horizontal axis? That's for your regular old real numbers. But the vertical axis, that's for the imaginary numbers. And now any complex number, a plus bi, becomes a point on a map with coordinates a, b. All of a sudden, the impossible became visible.
And this new map, it reveals this really cool hidden symmetry. For any complex number, there's what's called a complex conjugate. It's just its mirror image across the real axis. You literally just flip the sign of the imaginary part. Now, this isn't just a neat little visual trick. The conjugate is the absolute key to unlocking how we do math with complex numbers. For example, how in the world do you divide by a complex number? Well, the conjugate makes it surprisingly simple. The whole trick is to multiply both the top and the bottom of the fraction by the conjugate of the denominator. When you do that, the I on the bottom completely vanishes, because a complex number times its conjugate always gives you a real number. It turns a really complicated problem into simple algebra. It's awesome.
So this new ability to actually see and work with complex numbers, it just opened up an entire new world of geometric understanding.
So instead of thinking in terms of left/right and up/down coordinates, we can describe any point on this complex plane by its distance from the center and its angle. This is called polar form, and this is where the true power of complex numbers really starts to shine, especially when you're talking about things like multiplication and rotation.
And this leads us to one of the most profound discoveries in all of mathematics, thanks to a guy named Leonhard Euler. He found this shocking connection between two concepts that seemed totally unrelated: exponential growth, the number e, and rotation or waves, described by sine and cosine. And the magical key, The bridge that links them together is the imaginary number I. Now, what if we take Euler's incredible formula and we plug in a very special angle, pi? Well, the cosine of pi is -1 and the sine of pi is 0. So the whole thing simplifies down to this. E to the I times pi equals -1, or if we just rearrange it a tiny bit, we get what many people call the most beautiful equation in all of mathematics, Euler's identity.
And you can totally see why. Just look at the numbers in this one simple equation. You've got 0, the identity for addition. You have 1, the identity for multiplication. You have pi, the fundamental number for circles and all of geometry. You have e, the base of natural logarithms, the fundamental constant of growth. And you have I, the imaginary unit itself. 5 of the most important numbers in all of math, all tied together in one clean, profound statement. It's just perfect. This wasn't just beautiful. It revealed this deep, hidden unity in the structure of mathematics, a connection that absolutely no one had even suspected before the invention of I.
Okay, so I know what you might be thinking. This is all fascinating for mathematicians, but is any of this actually useful? Is it more than just some beautiful but totally abstract pattern?
Oh, the answer is a resounding yes. The mathematics of rotation and waves, the very stuff that Euler's formula so beautifully captures, that is the mathematics of our modern world. More specifically, it's the mathematics of alternating current, or AC electricity. The entire power grid that lights up our cities is designed and analyzed using the principles of complex numbers.
And the applications are they're everywhere. Because complex numbers can describe both size and rotation, they are perfect for analyzing AC circuits. Those same properties make them essential for signal processing in our phones and our Wi-Fi, where they help manage these incredibly complex waves. And in the truly bizarre world of quantum mechanics, complex numbers aren't just a tool, they are woven into the fundamental fabric of reality itself.
So yeah, the number that Descartes once dismissed as just imaginary turned out to be one of the most practical and indispensable tools in all of modern science and engineering.
This whole journey from an impossible little puzzle to the engine of modern technology, it really shows us something profound, doesn't it? That a purely abstract idea, born from refusing to accept impossible as an answer, can fundamentally change the world we live in. It really makes you wonder, what other impossible ideas are out there, just waiting for us to explore them?